In this video, I want to talk about equations for spheres and balls, otherwise known as solid spheres. A sphere is the set of all points that lie a fixed distance r away from a central point that is given by an ordered triple ABC. R is the radius of the sphere, and the point ABC is the center of the sphere. A sphere is a hollow object. A ball centered at the ordered triple ABC with a radius of r consists of all the points inside as well as on a sphere of radius r. A ball is a solid object. It is also commonly called a solid sphere. A sphere that is centered at ABC with radius r is a set of points that satisfy the equation given by x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is equal to r squared. A ball or solid sphere that is centered at ABC with a radius of r is a set of points that satisfy the inequality that is given by a x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is less than or equal to r squared. So let's work an example. I want to find an equation or inequality that describes each of the following. The first is a sphere centered at the point 1, 2, 0 and passing through the point 3, 4, 5. I also want to find the equation or inequality for a ball centered at the point 0, negative 2, 6 with a radius of 5. To find the equation or inequality for a sphere centered at the point 1, 2, 0 and passing through the point 3, 4, 5, I know that if I'm working with a sphere, it's going to be an equation that uses the form x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is equal to r squared. I know that a is equal to 1, b is equal to 2, and c is equal to 0. I set up my equation with those values. I get x minus 1 quantity squared plus y minus 2 quantity squared plus z squared is equal to r squared. And now I plug in the values x is equal to 3, y is equal to 4, and z is equal to 5 from the point I was given. And I get 3 minus 1 quantity squared plus 4 minus 2 quantity squared plus 5 squared is equal to r squared. This gives me r squared is equal to 33, so that my equation is written as x minus 1 quantity squared plus y minus 2 quantity squared plus z squared is equal to 33. Now to find the inequality for a ball centered at the point 0, negative 2, 6 with a radius of 5. I'm going to use the inequality form x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is less than or equal to r squared. I have a is equal to 0, b is equal to negative 2, c is equal to 6, and r is equal to 5. This gives me an inequality that can be written as x squared plus y plus 2 quantity squared plus z minus 6 quantity squared is less than or equal to 25. I want to work another example. I want to find an equation of the sphere passing through the point P specified by the ordered triple negative 4, 2, and 3, and the point Q specified by the ordered triple 0, 2, 7. And this sphere has its center at the midpoint of PQ. First, I have to find the midpoint of PQ using the midpoint formula. The midpoint of a line segment is given by the ordered triple x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. For our points P and Q, this midpoint is given by minus 4 over 2, 4 over 2, and 10 over 2, or the ordered triple negative 2, 2, and 5. The radius will be the distance from the center to one of our points. So my radius is given by the square root of 0 plus 2 quantity squared plus 2 minus 2 quantity squared plus 7 minus 5 quantity squared, which is equal to the square root of 8. This gives me the equation x plus 2 quantity squared plus y minus 2 quantity squared plus z minus 5 quantity squared is equal to 8. Now I could also have just plugged in the values for my center once I found it, and then plug in the values from either point P or point Q, whichever one will minimize the work I have to do, and found the radius that way. Let's work another example. I want to describe the set of points that satisfy the equation x plus 1 quantity squared plus y squared plus z squared minus 2y minus 24 is equal to 0. This is not in a standard form I recognize, so I want to get it into a standard form that looks something like x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is equal to r squared. I'll take my equation and add 24 to both sides. Then I'm going to need to complete the square on the y squared minus 2y portion. I add 1 to the left side so that my left side looks like x plus 1 quantity squared plus y squared minus 2y plus 1 plus z squared, but I have to add 1 to the right side as well, so this is equal to 24 plus 1. This gives me x plus 1 quantity squared plus y minus 1 quantity squared plus z squared on the left is equal to 25 on the right. This gives me a sphere centered at the point -1, 1, and 0 with a radius of 5. Now you try it. Pause the video and give a geometric description of the sets of points that satisfy the equation x squared plus y squared plus z squared minus 4x plus 6y plus 12 is equal to 0. When you are ready, restart the video to check your understanding. For this one, I need to complete the square for both the x terms and the y terms. I'm going to rearrange it in order to complete the square and get an equation that looks like x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared is equal to r squared. I'm going to rearrange my equation a little bit by subtracting 12 from both sides and putting my x and y terms closer together. I get x squared minus 4x plus y squared plus 6y plus z squared is equal to -12. I complete the square on the x terms and the y terms. X squared minus 4x plus 4 plus y squared plus 6y plus 9 plus z squared is equal to -12 plus 13. This can be rewritten as x minus 2 quantity squared plus y plus 3 quantity squared plus z squared is equal to 1. This is a sphere centered at the point 2, -3, 0 with a radius of 1. Working with spheres and solid spheres or balls is a great way to start thinking about working with equations in 3 dimensions. Let me know if you have any questions.